Okay guys, welcome back to grade 9 again. We're going to finish off the last of this chapter actually in the next couple of days. I'm going to post this video Friday morning, and then the work that I assign you can do Friday and Monday. I won't post anything new until Tuesday, so this actually can take you a couple of days to work through. That's fine. We're going to put it all together now. So you really have to know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. You really have to know those really well. If we were at school, I would be questioning you on them like every day. So you really have to know those and how they work. Also, the Pythagorean theorem. So you also have to know that a squared plus b squared equals c squared. And the third thing that you really should know is that all the angles in a triangle have to add up to 180 degrees. Those are really the three things you need to know. You need to know SOHCAHTOA, you need to know the a squared plus b squared equals c squared, and you need to know that all triangles add up to 180. Because now they're not going to tell you what you have to use. You are going to have to decide what you want to use. And you can actually do it a lot of different ways. There can be 5 or even 6 different ways to do a question, and you still could be getting the right answer. It still could be right, which again is why showing your work is so important, so that I can follow through the steps and make sure that you did all the steps logically. So I'm going to do a question from the textbook. I'm not actually going to look at how the textbook does it. I'm going to go through it once one way, and I'm going to go through it another way so that you can see that there's more than one way to do a question, and yet you can get the same answers. So for this one, the example number 1 on page 245 gives you a triangle, and I'll put it over here in this corner. And I'm not going to make it very big. Hopefully you can see it. If not, you have the textbook, I hope. So this is 11. This is 13. They call this A, B, and C. And the only instructions are, I thought I almost closed that book. I didn't. Sorry, the only things you have to find, there was a dog down there running around my feet. The only things you have to do is you have to find all the missing sides and all the missing angles. How you go about that is up to you. Sorry, again, I have a dog down here making weird faces at me for some reason. I don't know why. Okay, so all you have to do is find the missing sides, find the missing angles. There are different ways to go about it. Again, I'm going to do this question a couple of times. Same question, but I'm going to do it different ways. So the things we have to find, we have to figure out what angle C is. We have to figure out what angle C is. We have to figure out what angle A is. We have to figure out what angle A is. I just need space here. And we have to figure out what this side over here is. Now it's directly across from angle A, so I'm going to call it little a. Sorry, that was actually a dog, believe it or not. It's just a weird sounding dog. So that is little a. By the way, while I think of it, if you are stuck, you can re-watch this video more than once, So if you get stuck, before you start asking me a ton of questions, it might actually be answered in the video. Go back and look for that, okay? So we have to find 3 different things. It doesn't matter which one you find first, which one you find second, which one you find third. I'm going to find it in this order simply because that's the order I wrote it down in. But again, you don't have to do it this way. So if I was to find an angle C first, angle C, well, I know the opposite to angle C, and I know the hypotenuse to angle C. Opposite and hypotenuse signal that I should be using sine. So if I said sine of C, so the sine ratio using C as my reference angle is the opposite side, which is 11, over the hypotenuse side, which is 13. Looking for my calculator. So now, if I move this sine over here, C stays on this side, but sine moves. If all you're moving is the trig function, that's when it becomes that sine with the -1 on it. So you're going to have to hit your second function button of 11 over 13. And so if I do that, if I do shift sine of 11 over 13, whoops, sorry, I hit wrong buttons. Shift sine of 11 over 13, I get 58 degrees. And again, for angles, we round off to the nearest degree. We don't give decimals when we're doing angles. Don't give decimals. So now I want to find angle A. Again, you have options. My choice, because I think it's the easiest, my choice is if I know that this is 58, and I want to know what angle A is, and I know that this angle plus this angle plus this angle should equal 180 degrees, I would do 180 minus that 90 angle minus this 58 angle will give me what A should be, right? Because whatever's left over, that's what A should be. And so if I do that, I get 32 degrees. The only problem with doing it this way, the only thing that might make it so you don't get a right answer, well, A, you might hit something wrong on your calculator, but B, if you got this wrong, and then you used it over here, that's going to make this answer wrong. So it's a risk, but it's not that big a risk. Then I want to find angle A. Again, I can do that in a lot of different ways, actually. So in this way, I think what I'll do is I would do, because I know two sides and I want to know the third, I think what I would do is I would use a squared plus b squared equals c squared. Now remember, c is always my hypotenuse, so that's the 13. And the other two are going to be a squared and 11 squared. So I would have a squared plus 121 is 169. So I would subtract 121 on both sides, and I would get that a squared is 48. So I would take the square root of both sides to get just a, and I would get 6.9. Now if you read the instructions, they say when you're figuring out a side, round it off to the nearest tenth. So that's what I've done. I've rounded it off to the nearest tenth. So to figure out angle C, I used sine. To figure out angle A, I just used subtraction. And to figure out side A, I used Pythagorean theorem. I can do all of this in a completely different way and still get the same answers. So I'm going to leave the answers there, but I'm going to erase the work because I want you to see that I'm going to end up with pretty much the same answer. Something might be off by 1/10 or so, but I will end up with pretty much the same answer, and I'm not going to do any of it the same way as I just did it. I'm going to do them all differently. So let's say I'm going to start on this end this time. I'm going to figure out A. Oh, I erased those. It was 58 and 32, right? So I'm going to figure out A first. So if I want to figure out A, and I said I'm not going to do it the way I did it last time. I'm not going to use Pythagorean theorem this time. What I'm going to do this time is I'm going to, I can't figure out A yet because I don't have enough information if I'm not going to use Pythagorean theorem. So let me figure out angle A first. Angle A, I know from angle A, I know the adjacent side and I know the hypotenuse side. Adjacent and hypotenuse would be cos. So cos of A is the adjacent side, which is 11, over the hypotenuse side, which is 13. So again, I'm going to move the cos over here, and it becomes that arc cos thing. And so I go to my calculator and I hit shift cos of 11 over 13, and it tells me 32 degrees, which, remember, that's what I had before. Now that I know that that's 32 degrees, let me just fill it in. Now that I know that that is 32 degrees, if I want to figure out side A, I could do that now. And I could do that in a couple of different ways, but I'm going to pick one. Sorry, that's a dog coughing. If I start at angle A and I go straight across, I get to there, and I know my hypotenuse. So opposite and hypotenuse would be sine. So I could say that sine, using 32 degrees as my reference angle, is, so that's equals, the opposite side, and I don't know that one yet, that's what I'm trying to figure out, that's A, over the hypotenuse side, which is 13. So if I want to figure out A, I'm going to multiply this side by 13 so that those cancel, and I'm going to multiply this side by 13. So I have 13 times sine of 32 is what A is. So then I would go to my calculator, and I would do 13 times sine of 32, and I get 6.9 when I round it off to the nearest tenth. So same answer I had before, but I got it in a different way. So now if I want to figure out angle C, and again I said I was going to do this completely different from how I did the last question. So in the last question, when I knew one angle and I wanted to know the other one, I just subtracted 180 minus 90 minus the other angle. But I'm going to do it differently this time. So let's say I'm nervous that I got this wrong and I wasn't sure whether that was right. So I didn't want to use it in my calculation. If I want to figure out angle C, that from angle C, using C as my reference, 11 is the opposite side and 13 is the hypotenuse side. That would be sine. That's how I did it before. So let me do it a little bit differently, because that's how I did it before, and I said I was going to do it differently. So I could do that, which is what I did, but I could say, I know that this side is 6.9, or at least I hope it's 6.9. That's if I got that right. I could say that is the adjacent side, and that is the opposite side. And opposite over adjacent would be tan. I haven't used that one yet, so let's throw that in there. So I could say that tan of angle C, so using C as my reference angle, is the opposite side, which is 11, over the adjacent side, which is 6.9. So C would be arctan of 11 over 6.9. Now, calculators won't do a fraction with a decimal in it. So instead, I just do arctan of 11 divided by 6.9, and it works the same way. So shift tan of 11 divided by 6.9 gives me 58 degrees, which again is the same answer I had the other way, but I went about it differently. There's actually 5 or 6 different ways I could do this question. That's just 2 of them. It's up to you how you figure that out. Okay? Whoops. I'm dropping everything. Sorry. All right, so that's example 1. I'm not going to take as long on the other examples. That's just example 1, but I wanted you to see how there is more than one way to do these questions. Once you know like sine, cosine, and tangent, and you know the Pythagorean theorem, and you know that there's 180 degrees in a question. The next couple of questions are word problems, and you need to know a couple of terms. The first term that they're going to talk about They're going to talk about angle of depression and angle of elevation. So let me explain the difference between those two. When they talk about angle of depression, what they're talking about is that if I was standing on a cliff and I looked straight out, and then I looked down below me to see the boat that's in the ocean at the bottom of the cliff, the difference, the angle difference between me looking straight out and me looking down, that is called the angle of depression. So here's the cliff. If I look straight out, that's obviously 90 degrees. But if I look down, okay, if I look down, so there's like a little boat here. We all know how good my drawings are. There's my little boat, okay? So I look down at the little boat in the water. The difference between me looking straight out and me looking down, that is the angle of depression. That's the angle of depression. Angle of elevation is exactly the opposite. If I'm standing somewhere, it could be a cliff, could be anywhere, it could be this little dude on the boat, I don't know. If I'm standing somewhere and I look up, the difference between looking straight and looking up, that is called your angle of elevation. So let's reverse that. Let's talk about the guy in the boat. So here's the guy in the boat. If he looks straight across, that's just him looking straight out. But if he looks up to see me standing on the cliff, the difference between looking straight and looking up, that is the angle of elevation. So it's not that big a deal, except that they may use those words in a word problem, and so you need to know when you're drawing the picture what that actually looks like. So let's do, I did turn the page, see? All right, so let's do an example here. Example number 2 on page 246. Example 2 on page 246. And my board's going to fall off the wall if I'm not careful. Okay, page 246, you've got a lighthouse, and it sits on the top of a cliff. So here's the cliff, and on top you have a little lighthouse. It's the light coming up. It's a little lighthouse. My drawings are always so good. The top of the lighthouse is 33 meters above sea level. So here's the sea. So from the top of the lighthouse all the way down to where the water is, that is 33 meters. The angle of depression to sight a small fishing boat at sea is 24 degrees. So here's a little boat. Guy is standing at the top of the lighthouse, and he looks down at the boat. He looks down at the boat. The angle of depression, so the difference between him staring straight out and him looking down, is not 240, sorry. Whoa! I told you I'm dropping everything today. Is 24 degrees. How far from the base of the cliff is the fishing boat? So how far from the bottom of the cliff, how far out is it to the boat? So we're actually looking for this. So we'll put a little right angle there between the cliff and the water. So we actually have a right angle triangle. Now, we talked a little bit about geometry theorems at the beginning of this chapter. There's a geometry theorem that said if you have, it's called a shortcut for it is called the Z rule. But anyway, if you've got an angle on this side and another angle down here in this corner, opposite angles are actually equal. So this would actually be 24 degrees as well. Or you could say, listen, between here and here has to be 90 degrees. So if that's 24, I can figure out what this angle is because I can do 90 minus 24, and that is 66. It doesn't matter whether you use this angle or whether you use this angle. Whichever thing I just said that makes sense to you, use that, okay? So again, we're looking for here. We're looking for the distance between the bottom of the cliff and the boat. We know this side is 33. So let's say we're going to use this one as our reference angle, this 66. And again, we got that because we knew that was 24. And so whatever this one is, this and this have to add to give you 90 degrees. That's how we did that. So here, from this reference angle, I want to know the opposite side, and I already know the adjacent side. So that means I should use tan. So tan of 66 degrees is the opposite side, which I don't know, over the adjacent side, which is 33. Okay? So then I go to my calculator. I'm going to multiply this side by 33. So I'm going to multiply this side by 33. And these will cancel. So I'll have 33 times tan of 66. And that's going to give me 74.1. But again, this is a side. So we're going to round it to the nearest tenth. 74.1 meters. So the boat is 74.1 meters away from the base of the cliff. So hopefully he's seen the lighthouse and knows there's a cliff and isn't going to run into it and sink. Last example we're going to do. I keep pausing because I want to give you time to write it down. I keep forgetting you guys can actually pause the video. Example number 3 says ropes are used to pull a totem pole upright. So we have a totem pole. We'll put little happy faces on the totem pole. Okay, we have a totem pole. And there's ropes attached and anchored into the ground to hold the pole in place until they can fill the hole in and make it more secure. The ropes holding the totem pole is 18 meters long. So there's a rope coming off of here. So here's the ground. There's a rope anchoring the totem pole in place. That rope is 18 meters long. And it makes, that rope makes an angle of 48 degrees with the ground. So here's the rope, here's the ground, angle 48 degrees. You really have to get used to reading what they say and then placing it in the right place in your triangle. That can be difficult. Again, just take it one piece at a time. Try and get that piece in the right spot and then move on to the next one. Now it says, find to the nearest meter. The first thing it wants to know is the height of the totem pole. So we want to know this over here. So again, we'll just call it X because that's what we're looking for. So that's the first thing. It asks for two things, but that's the first one. So we'll deal with the first one first because that makes sense. So if this is my reference angle, and let's give it a label. Let's call it A. Doesn't really matter. If we say that this is 48, we want to know this side, which is opposite. This side is the hypotenuse because my right angle is right here. So opposite and hypotenuse mean I'm using sine. I recommend if you're writing a test or something or an exam, hopefully we'll be back by exam time. If you're writing an exam, that you actually just write that at the top of your page so that it's an easy thing to follow. So opposite over hypotenuse. So we say sine of my 48 degree angle is the opposite side, which I don't know, over the adjacent, over the hypotenuse side, which is 18. So I'm going to multiply this side by 18, and I'm going to multiply this side by 18. So I'm going to have 18 times sine of 48 is 13.4. So the totem pole is 13.4 meters tall. So that's part A. That's what they wanted to know in the first question. Second question that they have is how far from the anchor point to the bottom of the totem pole? So they want to know this. So let's give it a different letter. Let's call it Y. Again, if I want to use 48 as my reference, I could do that for part B. I could say this time I want to know the adjacent side, and I know the hypotenuse side, which would be cos. Cos of 48 degrees is the adjacent side, which I don't know, over the hypotenuse side, which is 18. So I'm going to multiply this side by 18. So I'm going to multiply this side by 18. So I have 18 times cos of 48 is Y. So I just put that in my calculator. 18 times cos of 48 is 12.0 when I round it off to the nearest tenth. Now, if I had wanted to, if I was pretty sure that I had gotten this side right, that was 13.4, and I knew that this was 18, I could have used a squared plus b squared equals c squared to figure out this side. That would have worked as well. More than one way to answer these questions. So the whole point of this section is if it says to solve the triangle, that means you're going to find all the missing sides and all the missing angles. Otherwise, you find whatever it is they're asking you to find. More than one way to do it. So you have to, this is mostly for Carson, you have to show me how did you do it, because if you don't, I don't know where those answers came from. So please make sure that you're showing me your work. I'm going to post this Friday morning, and I'm going to post questions. I'm not going to post anything new for questions until Tuesday. This is the end of the chapter. This is the end. So on Tuesday, what I would like is by Tuesday, if you could let me know, actually by as early as you can on Monday, like by 3 o'clock on Monday, if you could let me know if you have any specific questions, because I'll do them. If not, then I'll make a video on the review of chapter 6. And then I think what I'll do is, rather than a test per se where you only have an hour to do it, what I'm going to do, I think, is I'm going to make up a chapter 6 assignment, much like I did over the week before March break. I'm going to make an assignment, make it maybe a 2 or 3 day due date, and you will have those 2 or 3 days to do it, and then you'll have to hand it in by a specific time within those 2 or 3 days. So rather than a test, an assignment, I think it's probably just the easiest way to go when it comes to math, okay? So that's it. Sorry, this one was a bit longer. See you again Monday, I guess. Monday, Tuesday? Tuesday. Bye.